In this question, look at the op-amp circuit. The given op-amp circuit is Schmitt trigger. For this Schmitt trigger, you are going to calculate upper and lower threshold voltage, that means UTP and LTP. Given that one, reference voltages are plus 15, minus 15. Okay. And Schmitt trigger implies positive feedback. It uses positive feedback and it generally converts an input signal. Whatever the input signal you are applying, it may not be sinusoidal always. Whatever the input signal it is you are applying, that will be converted into square waveform if some condition is going to be satisfied. That means conditionally it will convert any input signal into square waveform. What is that condition means? For any input signal, you will have a positive peak as well as you may be having negative peak. It may be sinusoidal or it may be non-sinusoidal or any waveform. Okay, whatever the irrespective of input waveform, you will have a positive peak, that is the highest positive value, okay, and negative peak, lowest negative peak. Okay, if the positive peak is going to be greater than upper threshold point and negative peak is less than lower threshold point of input waveform is satisfied, then that will be converted into square waveform. V out is square waveform. Okay, now since it is using positive feedback, okay, output voltage may be at plus 15 volts or it may be at minus 15 volts. Okay, so plus 15 volts when it happens means whenever non-inverting terminal is dominates the inverting terminal voltage. If non-inverting terminal voltage is greater than, that means voltage at this point, if it is greater than the voltage at this point, then output will be at plus 15, otherwise output will be at minus 15 if inverting terminal is dominating non-inverting terminal voltage. Okay, now we are going to calculate UTP and LTP. First we will calculate it about UTP. UTP means upper threshold point, is the input voltage at which output makes transition while the input voltage is moving in forward direction. Okay, write it. UTP, upper threshold voltage, is the point, is the input voltage at which output makes transition either from plus VCC to minus VCC or minus VCC to plus VCC. Okay, it is generally from plus VCC to minus VCC only while it is moving in forward direction. Okay, upper threshold point is the voltage, is the input voltage at which output makes a transition from plus VCC to minus VCC as the input voltage is increasing in forward direction. Now that we will see graphically. With respect to transfer characteristics. So transfer characteristics means x-axis is V in and output is V naught. Okay, it is 0. Forward direction of input, that means input is increasing from minus infinity to plus infinity. Forward direction means it is increasing from minus infinity to plus infinity, remember that one. So since the input voltage is going to be very small as it is starting from minus infinity, always voltage on non-inverting terminal dominates. That means you will be falling in this case. V out. The V out, whatever it is previously, the voltage at non-inverting terminal at most may be derived from minus 15 volts and this is plus 3 volts. If it is at previously plus 15, doesn't matter, always this voltage is positive. If previously, let us assume at the time of power supply on, switched on, if it is at minus 15 also, minus 15 and plus 3 volts are contributing the voltage to change across this point, that is somewhat negative, but that negative voltage is in magnitude, it is very large compared to input voltage which is starting from minus infinity. So always the case is nothing but in this way. This is the case. So output voltage will be always plus VCC, that means plus 15 volts. So now output voltage is at plus 15. Whenever it is at plus 15, you are going to get some voltage here. That voltage, we assume that one V plus. Find out this voltage whenever output voltage is plus 15 and 3 volts is the reference. Then as the input voltage is reaching this point, up to this point, the output will be at plus 15. Whenever input voltage is greater than this V plus, output will be shifted towards minus 15. That is where you are going to get the transition. That point is like this. So this is that voltage of V plus, which we are treating it as UTP, upper threshold point, as input voltage is moving in forward direction. This arrows indicates input voltage is moving in forward direction starting from minus infinity to plus infinity. So this is UTP definition. UTP is the input voltage at which output makes a transition from plus 15 to minus 15 when the input voltage is moving in forward direction. Okay, the value of UTP can be calculated by using V plus. Okay, so V plus is equal to, first you have to calculate using 15 volts. Okay, and next you assume that one you are going to calculate V plus using 3 volts. That means using superposition theorem you are going to calculate using superposition theorem. V plus is equal to plus 15 volts. If you consider the voltage at V plus is equal to voltage up across 5 kilo ohms. By that time you will assume that 3 volts is grounded. So this will be equal to 5 divided by 5 plus 10 into 15 plus, if you assume 3 volts, 15 volts will be grounded. Then it will be 10 divided by 10 plus 5 into 3. So the value is 15 get cancels, you will get 5 volts here, and 10 by 15, 30 by 2 is nothing but 7 volts. So V plus is nothing but 7 volts. Okay, so plus 7 volts is V plus. Directly we can say the right answer is B. No need to calculate LTP because there is only one option which consisting of plus 7 volts. Now we will see how to calculate LTP. Okay, LTP, lower threshold point, is the input voltage at which output voltage gets a transition from minus VCC to plus VCC when the input voltage is moving under reverse direction. LTP is the input voltage at which output takes a transition while input is moving in reverse direction. That means whenever the input voltage is moving from minus infinity to plus infinity to minus infinity. Okay, so already output voltage, that is output voltage is at minus 15 volts because input voltage, it is starting from plus infinity. It is starting from plus infinity. So always non-inverting terminal dominates. So output will be at plus 15 volts. Okay, when V minus dominates V plus. Inverting terminal voltage dominates non-inverting terminal voltage. So this means minus 15 and this is plus 3. You are going to get some voltage. That means non-inverting terminal voltage as negative voltage because negative voltage is more compared to positive voltage applied over here, the same node. Okay, so this negative voltage up to this point, output voltage will be at minus 15 and after that output voltage is shifted back to plus 15 volts. This point is stated as LTP. LTP is the input voltage at which output takes a transition from minus 15 to plus 15, while the input voltage is moving in reverse direction. That reverse direction is indicated with the arrows as shown towards minus infinity. So we are going to calculate VLTP. VLTP is nothing but again the non-inverting terminal voltage when the output voltage is at minus 15 volts. So calculate VLTP is equal to V plus, okay, that you are going with ones plus minus 15, and next you are going to calculate using plus 3 using superposition theorem again. So if you use superposition theorem, VLTP, you are assuming minus 15. When you assume minus 15, 3 volts is going to be gets grounded, then it will be 5 divided by 5 plus 10 into minus 15 plus, if you assume 3 volts, okay, then minus 15 will be grounded, then it is 10 by 10 plus 5 into plus 3. So it is 15 get cancels, it will be minus 5 plus 10 by 15 32, that means minus 3 volts. VLTP is minus 3 volts, VUTP is plus 7 volts. So the right answer for this one is B. And if you draw both on same line, you are not going to get VLTP and VUTP same. Then the difference between VLTP and VUTP is treated as hysteresis loss. So if you draw UTP diagram and LTP diagram, both are superimposed, this will be treated as UTP, and the difference what you are going to get is called as VH, hysteresis loop. VH is equal to VUTP minus VLTP, that means 7 volts minus of minus 3, so it is 10 volts. Hysteresis voltage is 10 volts for the given circuit. Thank you.